running on Kubernetes without being aware of what pods requests and limits are is like spending money without being aware of your budget. Engineers often don't know what requests and limits are, how to control them, how to use them, and what happens when something goes wrong. So they find themselves spending a lot of money on cloud resources or the application getting killed by Kubernetes. This is why I've created this video to make sure that each one of you knows what pod requests and limits are, how to control them, and what happens when something goes wrong. There are two resources which every application in the world needs in order to run: CPU and memory. The application is actually worthless without those. When our application runs on Kubernetes, it runs within a pod, and the pod runs on a node. The pod in our application consumes the memory and the CPU of the node they run on. It means that all the pod within the same node actually sharing the same CPU and memory. Why do you should care about these kind of things? The pod, the resources, the node, the memory, it's very confusing, all this stuff. So, for your application to run well, it's need basically two things. First of all, you want to make sure that your application have enough resources in order to run. You want to reserve maybe some of the resources, because if your application needs one CPU and half gigabyte of memory, you need to make sure that each node it's going to be scheduled on got enough resources for it to run. It's like the minimum requirement when we buy a new game or we run new software. We want to make sure we have the minimum requirement in order to run. The second thing is about the limit and how much resources we can consume at maximum. We don't want our application to go crazy and consume all the CPU and all the memory within the node it runs on. Why? First of all, it means that our application do not operate well. And second of all, it means that we may impact other applications within this node. So we want to have a maximum requirement for application that if it needs to go through, we need to make sure that we kill it. And we signal to the developer or for yourself that this application consumes too much memory, consumes too much CPU. From the application perspective, the minimum and maximum requirements are enough to run. But when we take it to a wide scope, why should we plan the resources? So first of all, we want to make sure that we know how much we are going to pay. We pay for the cloud provider for CPU, memory, and machines. We need to understand that we do not consume a lot of CPU memory because then our application will be not cost effective. And we want to make sure that we keep the price as low as we can in order for application and business to run. The second thing is about noisy neighbor and availability of our application. We want to make sure that if one service go crazy and consume a lot of memory and CPU, it will not impact the other application running within the cluster. So we actually contain the risk of having one application go crazy and disrupt other pods or application within the cluster. We call it the noisy neighbor. Now let's move on to what are request and limit. For each container within our pod, we can configure two things: the request, how much resources do we want Kubernetes to find and reserve within the node this pod is going to run on, and we can limit the resources and make sure Kubernetes is going to impact the application when it's going to consume more resources than we defined, the maximum requirement for this application. I want to talk a little bit about the configuration and the units. So where we do configure request and limits, in each container we got the resources section, and there we can define request and limits, and for each one we can define the memory and CPU required. And what are the units involved in this configuration? So memory, the unit will be bytes. It means megabyte, gigabyte, mebibyte, or any other byte version. For the CPU, it will be how many cores of CPU our application needs. It can be even a fraction of it, like half core or 1/4 of a core. It depends on how much we need. How the CPU is breakdown, basically the operating system is slicing time frame like seconds, and for each time frame it's sharing the CPU between all the containers need that. When do Kubernetes takes the request configuration into consideration? It happens during the scheduling process, when a new pod is created and Kubernetes is looking for a new node for it to run. Then Kubernetes will check the request requested for resources and take a look on all of the nodes within the cluster and find the right run for it. So let's say, for example, that we got one pod and with one container and we requested 800 megabytes of memory. Now Kubernetes is looking for all of the nodes and find the right one for it to run. If there is no one available, then the pod will be pending for scheduling or will fail scheduling, depends on the time frame. In general, what happens when a pod is pending? We are waiting for the cluster scaler to spawn up a new node and then our pod will be run on it. When do limits take into consideration? Anytime our pod are running, Kubernetes monitors the usage of memory and CPU and see if none of them actually hits the threshold. So basically, it uses the operating system in order to do two things, and here is where memory and CPU are a little bit diverse. If we reach the maximum amount of memory that we defined on limits, Kubernetes is going to kill the container with out of memory killed signal. On CPU, it's a little bit different. In CPU, if our container reaches the limits of CPU, Kubernetes will give this container less CPU cycles than before. It limits the CPU cycles, but it would not kill the pod. It means that our pod will be slowed down a little bit. This is why it's so hard to catch. We just see that something really slowed down with our pod and we don't know why. And this is why the difference is so confusing. So always remember, memory, out of memory killed, CPU, slow down. When you set the limits and requests to the same amount, it means that you reserve all the resources that you need. Probably you are going to spend resources because you are not going to use the high amount all the time. So the diff will be a resources that are reserved for your containers and application, but no one used those. So it's a waste of resources. On the other side, when we define the request a little bit lower than the limits, it means there is a diff where everyone can use it. So we can dense more containers and pods to the same amount of nodes, which is great because we can save some money and save some resources. On the other side, it means that if something happens and all the application, all the containers need the max, obviously there are not enough resources and all of them will be slowed down or some of them will be killed. So there is a risk involved in here, and you need to consider how much risk do you want to take in place. I would recommend to start from something and then watch the metrics. You can see the metrics in Prometheus, Grafana, Datadog, New Relic, even with Kube metric state, and watch them over time and understand what is the values that should be set for you, and then define the request and limits based on that. There is one more thing very interesting about request and limits. It's not only define our application request and limits, it also defined our importance of the application for Kubernetes. Then Kubernetes knows how critical this application for us. Why is that important? Because in a certain state, when, for example, there is no enough memory on a node, then Kubernetes needs to decide which application must be killed. So for example, if we have a pressure on the node, there is not enough memory, so Kubernetes will pick the lowest priority application and it's going to basically kill it. How is that happening? How we define the quality of service? So when we define the request to be equal to the limits, it means that this application needs to be reserved all the resources from the time it starts. This is called guaranteed quality of service because we guarantee the resources all along the way. A little bit lower, we got burstable quality of service when we define the limits to be a little bit higher than the request. It means that for burstable amount of time, our application is going to consume more than the request, but lower than the limits. And the last quality of service is best effort. If we do not define anything, this is the lowest priority of our application to be in. So anytime you start to run a pod, check the quality of service. Make sure it matches your business needs and what you expect to happen when something goes under pressure. There is a movement within the Kubernetes community that claims that CPU limits should not be set. Why is that? Because when you set a CPU limit, your application is going to be slowed down when it reaches the limit. And obviously, if there is CPU available, you want it to use it. The other thing is that CPU is a resource which is not always on shortage. Usually, in most of the cluster, memory is the resource on shortage, but the other side of that is the quality of service and the resource consumption that can be involved within that. Obviously, when one of the containers go crazy and consume all the CPU in the node, it will impact all the application in the cluster, and that can be a big problem. And the second thing is the quality of service is going to be impacted if you do not set the limit, because if you want to be guaranteed to be run, you will be at least going into burstable or even best effort, which you don't want. My recommendation is to set limits, but to be very careful about those. Now you are experts in pod request and limits. What you should do next is go to your service. See if you got requests and limits. If not, add those. If you don't know what to add, go to the metrics dashboard, find the right things or the right values that you have in place, what you consume, and then add those. Make sure that you never run your service without requests and limits in place. The next thing that you should do is click on the like button or the subscribe button. Thank you very much.